Hello y'all, we are Memphis Communiversity and today we're back for another calculus done wrong lesson where we wrong calculus before calculus wrongs us. Today what we're going to be doing is we're going to be doing a very important lesson. Also it's an easy lesson, so I like that combo. We are going to be talking about the power rule and then we're going to do a few more derivative properties. But the first half of this video will be about the power rule. Let's get started. The power rule is the most important derivative topic and it's the easiest one to use. You're going to do this 1,000 times in calculus and you're going to want to do it 1,000 more times. So let's talk about what the power rule says. So because we're teaching calculus wrong, we're not going to prove the power rule. It comes from the definition of derivative as a limit and it involves the binomial theorem. But for now, what we want to do is just state the rule and then just practice it as much as possible because it is so exciting. So what does it say? Well, it says if you take a derivative, and remember that this is a verb, meaning I'm going to take the derivative of whatever I'm about to write. Don't worry, I will write something. So whenever it's going to come in these parentheses, I'm going to take the derivative of this. So what we're going to try to do is take the derivative of things like x to the n. And how you do it is you just take your exponent. For example, this will be like x squared, x to the fourth, x to the 1/2, x to the -5. And what you do is you just take the exponent and you just bring it to the front instead. So it's going to be n times x. And then you're going to lower the exponent by 1. You're going to subtract 1 from the exponent. And that's all it is. Again, all you do is you take your exponent, drag it to the front, and then subtract 1. So let's practice this a bunch of times. Let's just see this in action. So let's write the power rule in the corner here. Again, to take a derivative, all you do is you drop the power to the front and subtract 1. Don't have enough space here. Let me try one more time. So when you take this derivative, it's going to be n times n x to the n minus 1. So let's try this with a few examples here. So I'm going to erase this. This is the power rule. You know what rule we're doing. Let's get started. So for example, let's take the derivative of x to the 5th. Let me try to write a better 5 for you. X to the 5th. So again, all you do is you take your exponent, take your little hands right here, just bring the exponent to the front and subtract 1. So when we bring this 5 to the front, 5 times x, and then we subtract 1 from the exponent. 5 minus 1, of course, is 4. So that's all it is, and we are done. So notice how easy this question is. Let's practice again. So let's say we have the derivative of something like x to the 200. You will never encounter an exponent this big, but I don't know of your life, but even if you were to, let's take this derivative. Again, you take this exponent with your dainty little hands, bring it to the front, and then subtract 1. So in this case, it's going to be 200x to the 199. So you can see that this is very easy. This works for any single number in the world. So let's say we have derivative of, for example, x to the pi. Well, what's this derivative? Again, even if pi is a little bit weirder of a number, all you do is you take the exponent, bring it to the front, and subtract 1. So in this case, we're going to bring the pi to the front, pi to the front right there. We're going to write it x, and then our new exponent is going to be pi minus 1. So this is just going to be pi minus 1. We don't know what pi minus 1 is, so we're just going to leave it as pi minus 1. But hopefully you see how easy this is. Just dropping it to the front, dropping this exponent to the front, dropping this exponent to the front, and remembering to subtract 1. One of the easiest things you do in calculus, and you'll do this again 1,000, 2,000, 3,000 times. So let's try some harder examples. Because this rule is so incredible, we're going to be trying to do this rule as much as possible. Sometimes we're going to have things that are not written as powers, but we're going to try to convert them as powers. We're going to try to write them as x to a certain number so that we can employ the power rule as much as possible. It's my favorite thing in the world. I live a crazy life, I know. So let's try to take a derivative like this, for example. This is going to be x square root of x. So again, I'm trying to use the power rule as much as possible, and there's a way to write square root of x as a power. So what I'm going to do is, before I take the derivative, I'm going to rewrite it as that exponent. So it's going to be derivative of x to the 1/2. Remember, this is what square root means. It means you're having fractional exponents. So let's take this derivative. Again, just take your power, drag it to the front. So it's going to be 1/2 x. And then remember that you have to subtract 1. So you have to be a little bit good with fractions if you're introducing fractional exponents. But it's not too bad because you're always just subtracting 1. We can do that in 2 steps for you. So when you subtract 1, the common denominator will just be the sorry, I don't know what I'm saying, the denominator of the original thing. So it's going to be 1/2 x to the negative 1/2. And that's all it is. So again, because we love the power rule so much, we're changing these square roots to fractional exponents to allow us to employ the power rule, because you need a power to employ the power rule. Potentially though, you might need to do more math on the side. For example, you might want to plug in the number 9 in a later part of the question. So what I say is change it back to a square root when you have the opportunity to after you take the derivative. So again, the 1/2 means that it's a square root. The negative, as we'll talk about in a minute, means that it's going to be in the denominator. So in this case, you can simplify this to be 1/2 x to the 1/2, which is the same thing as 1/2 square root of x. So let me just recap for you again. We want to use the power rule as much as possible. So we change square roots to powers to take the derivative. But once we've taken that derivative correctly, and I believe in us that we will, we're going to change it back potentially if we wanted to simplify it, because it's easier to plug in. For example, 9, you get 1/2 times the square root of 9. That'd be 1/2 times 3, which is going to be 1/6. So again, change things to powers to take the derivative, employ the power rule, and then once you're done, if you want to, if you feel the need to, change it back away from powers with square roots in order to help yourself. So let's see a similar example to this. So let's take the derivative of, let's say 1/x to the 10th. So again, I want to use the power rule as much as possible. That's my dream in life. That's the thing I wanted to do ever since I was a little kid. So how do we change this to be a power? Well, remember that that's what negative exponent means. Negative exponents mean that you're taking things to the denominator. So if you already have something as a denominator, some number over x to a number, that's going to be the same thing. So this is going to be a rewrite as x to the negative 10. And now that I have it as a single power, it is in the form of the power rule, so I can take this derivative. So what's the derivative of x to the negative 10? Well, again, you take your little fingers, drag it to the front, subtract 1. Be careful when you're subtracting 1, of course, but it shouldn't be too bad. Looks like we're going to get negative 10 because I brought it to the front, x. And then what's the new exponent? Negative 10 minus 1 is negative 11. So this is going to be negative 11, and this is the answer. Again, if you might need to simplify, well, that's going to be okay. Remember that the only thing that is to the negative exponent is this x. So when you take the x to the downstairs, the 10 remains in the numerator. So if you wanted to, you can simplify this to be this. But hopefully you can see the power of the power rule. What a crazy thing, because it allows us to take the derivative of not only things like x to the 4th, x squared, x to the pi, but it also allows us to take the derivative of the square root of x. And these sort of fractions as well, 1/x to the 10th. So let's do one more example of this, and then we'll start talking about other things as well. And then we'll use that in conjunction with the power rule. And you'll see that even after this video, you'll be able to take a lot of derivatives. And then as you watch more and more of our videos, you'll be able to take all the derivatives in the world. So let's erase this. Leave the power rule up because it's so lovely. So here we go. Let's take the derivative of something like just number 6 to the x. So you're going to be taking these derivatives also pretty commonly. These are actually easier. So a lot of people know that the derivative of a constant times x is just that constant. There's many ways to think about this. You can use the definition of the derivative. You can use this as the slope of the line. Well, what's the slope of 6x? It's just going to be 6. Another way is to employ the power rule. Technically, 6x is 6x to the 1. So to take that derivative, you drop the power to the front. So it's 1 times x. You subtract 1 from the exponent, so it's 1 minus 0. X to the 0 is 1. So basically, whenever you have a constant times x, the derivative is just that constant. So why don't you practice one power rule example by yourself. I won't watch you, I won't put pressure on you. Try to do it by yourself. Let's try to take the derivative of x. Let's maybe put cube root to the 4. So let's see if you can do that. Again, the suggestion is change this to a power and you should be fine. So let's try to take this derivative. I won't look at you. I'll give you 3 seconds. 1, 2, 3. Let's see what you got. So again, the most important part of this is the exponent law. The law you might have learned in Algebra 2 or pre-calculus that allows us to use the power rule. So in this case, remember that if it's a root, some teachers teach that the root is in the denominator of our fractional exponent because roots are like trees or something, I don't know. So this is not going to be the exponent 3 to the 4th, it's x to the 4th, so it's going to be 4 over 3. Again, the root is in the denominator. So once you have this, it should be pretty easy to determine what the derivative is once we employ the power rule because it's easy to use. So what we're going to do again is take this power, drag it to the front. So that's going to be 4/3 x, and then we're going to subtract 1 from 4/3, but that's just 3/3. So 4/3 minus 3/3, of course, is just 1/3. And again, if you want to, if your teacher forces you, because they're the worst, if you want, you can simplify this as a cube root if that looks nicer to you. So you can write this as 4/3 to the cube root of x. I don't even know what I'm writing anymore, but hopefully that makes sense. So again, power rule, so useful, just able to take so many derivatives of these monomials, I think is what it's called, just x to a single power. But now we're ready to take the derivative of polynomials as well as a few more functions. So this is the second half of the video. We're taking the power rule and then we're going to extend it. Just like before, we're not going to prove the rules that I'm about to talk about. We're just going to try to employ them as much as possible. So forgive me for that. But let's list out what other derivatives we want to know sort of at a basic level right now. So here we go. So just like before, what we mentioned is that the derivative of a constant times x is just that constant. For example, the derivative of 6x is 6. The derivative of negative 8x is negative 8. The derivative of pi x is pi. So that one's pretty simple. Even simpler is that the derivative of any constant, so no x's at all, is 0 because you have a horizontal line. So the derivative of that horizontal line is just 0 because the slope of that horizontal line, no matter where you are on the line, will be 0. So that's a pretty easy one. So the derivative of negative 7, square root of 12, e, pi to the 4th, all of those are just 0, ln of 8. So that's one of the easiest things to know. The derivative of constants is equal to 0. So now what we want to do is not just take the derivative of just like x to the 5th, but we also want to take the derivative of x to the 5th plus x cubed or something like that. So one rule that you're going to be sort of taking for granted probably, you're just going to use it so often that you will know it, even if you don't know if you know it, if that makes sense. But the derivative of a function times plus another function is going to be just take the derivative of the f and then you take the derivative of the g and then just add them together. So really it's just a separate question. So it's going to be the derivative of f of x plus the derivative of g of x. And again, this does come from the definition of the derivative. If you set up those limits and you added them together, you would be able to get this. But for now, we're just going to take them for granted. So the derivative of a sum is equal to the sum of the derivatives, as we'll see in some examples. And it also works with subtraction, so we'll write subtraction here. So the derivative of a difference is just the difference of the two derivatives. Keep in mind that this does not work with a product of functions or quotient of functions. That will be in a few videos from now. That's going to be the famous product rule and quotient rule, where those have very specific rules, and those are a lot harder to do. But for now, sums and differences are usually pretty easy. Another thing we're going to talk about, or we're going to take sort of for granted, is that if you have a function times a constant, how you take the derivative of that? Well, you just take the derivative of the function and then just multiply by the constant. The constant really you can just take outside of the question. So again, the derivative of a constant times a function, we're just going to take that constant outside, so it'll just be the derivative of the function. Wanted to write an f for some reason. The derivative of a function times a constant. So that's that. So again, we're going to be using this a lot, especially with the power rule. So for example, if we're taking the derivative of something like 4x to the 5th, well, we're just dropping down the 5. So that's going to be 5x to the 4th, but there's originally a 4 in the front, so that'll be 20x to the 4th. And we'll see that. It's not going to be too bad. Finally, we're going to talk about two different derivatives that are not polynomials. They're going to be exponentials, but I think it's good to introduce these two. Usually my students memorize these two, and it's good to practice with them, especially with these rules right here. So what am I talking about? Well, the derivative of e to the x, the exponential e to the x function. It's the best function in the world. Some books actually describe e to the x as whose function is the derivative of itself. So in this case, what is the derivative of e to the x? It's just e to the x. So nothing too crazy here. And then finally, we're going to take the derivative of something else. This appears a little bit less often, but it does appear on calculus exams. It's going to be the a to the x rule. And so look at the big difference between the power rule and the a to the x rule. They're totally separate. So the power rule, which you're going to use a lot more, is x to numbers. So for example, x squared, x cubed, square root of x, which is x to the 1/2, 1 over x to the 8th, that's x to the negative 8th. All of those were power rule questions. These questions are x and the exponent, the numbers in the base. So for example, 3 to the x, 5 to the x, pi to the x. So notice that it's totally different questions where you do the power rule if x is in the base, and you do the a to the x rule when x is in the exponent. And what it says is the derivative is a to the x ln a. So just keep in mind it's ln a. That's just the rule. So for example, the derivative of 5 to the x is 5 to the x times ln 5. The derivative of ln 11 to the x would be 11 to the x ln 11. It's not the x, it's ln, the number, so ln 11. Even this e to the x rule comes from this rule as well. The derivative of e to the x would be e to the x times ln e, and ln e is 1. So these are our main derivative rules. Let's just go over them. Power rule we talked about before. Take the power, subtract 1. Derivative of just a constant times x, that's just a constant. If you have just a constant, the derivative is 0. That one is really, really nice. The derivative of sums and differences is you just take the sums and differences separately and then you just smush them together basically. And then if you have a constant, we just drag the constant out, do all of your work, and then just put the constant in the front. And then finally, the derivative of e to the x is e to the x, the derivative of a to the x is a to the x ln a. And of course, there's more derivatives, especially the trig functions, but that's going to be in the next video. So let's practice all these rules with us for maybe 3 examples or so. So let's see what we got. So I'm going to erase this guy right here. I'm going to erase this. I'm going to erase this. Let's just erase everything, even the power rule, because I think we'll know the power rule. Let's see if we remember it throughout these examples. So my first example is going to be f of x equals x to the 8th plus 3x to the 5th minus, let's say 2x to the 3rd plus 7x minus 3. So hopefully you can see that minus 3 squeezed in. So again, notice that this function is a lot more complicated than our first half of our video, but it's going to be okay because we're just going to keep all these things separate. We're going to take the derivative of this thing, and then we're going to add. We're going to take the derivative of this thing, and then we're going to subtract. Then we're going to take the derivative of this thing, and then we're going to add, take the derivative of 7x, and then we're going to finally take the derivative of minus 3. So again, when you're separated by pluses or minuses, that's a good thing. You just take all of them one at a time, just smaller questions. So let's get started. So this x to the 8th one is just like the previous one. What you do is you take your 8, take it to the front, so that's going to be 8x. Subtract 1 from the new exponent, so that's going to be 7. So that's going to be the first thing. Now we're going to take the derivative of 3x to the 5th. So as we said before, sometimes you'll have constants attached to the functions, but it's going to be okay. What you do is just cover up the constant, take the derivative, and then just attach 3 to the number. So if you want, for this first time, I'm just going to write it out. So if you have the 3 here, just write the 3, and then take the derivative of x to the 5th. What's the derivative of x to the 5th? Just like our friend Snoop Dogg said, you drop the power like it's hot, and then you subtract 1, so that's going to be 5x to the 4th. This will eventually become 15. So if you see what happens, you take the exponent to the front and you multiply it by the number because the number is just sitting there, and then subtract 1. So in this case, if you want to practice, well, you just take the power to the front. The 2 is already there, so you multiply it, so that's going to be minus 6x squared. Boom. And then finally, the derivative of plus 7x, remember the derivative of a constant times x is just that constant, so it's going to be plus 7. And then finally, the derivative of minus 3 is 0. So that's going to be 0. This is f prime of x. And that's all it is. So let's practice again with similar examples. So let's do f of x equals 8 e to the x, let's say minus 3 square root of x plus 7 over x to the 8th. Maybe not x to the 8th. I like x to the 4th better right now for some reason. And then finally, let's just subtract off the number 102. Hopefully you can see that the number 102 is actually not too bad because it'll just go away when we take the derivative. So let's go for this. So again, you have a function times a constant. So to take the derivative, all you do is you write the constant and then write the derivative of the function. So it's going to be 8. And then what's the derivative of e to the x? Well, e to the x is the best function in the world. Its derivative is itself. So it's just e to the x. Then we come to this guy right here, minus 3 square root of x. So again, we love the power rule so much. What we want to do is we want to convert this guy, and we might as well convert this guy as well, the powers, and then that will allow us to take the derivative easier. Sometimes my students will rewrite the entire thing, but sometimes they'll just write it underneath or below it. So this is going to be 3 times x to the 1/2, because again, square root of x is the same thing as x to the 1/2. So what we're going to do is we're going to take the 1/2 to the front. When we take 1/2 to the front, we're going to get minus 3/2. And then we're going to subtract 1. So again, don't worry about this constant, just drag it to the front. It's going to be 3/2. And then finally, we're going to subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. So we're just going to get negative 1/2. Then same thing here. What you should do is you should rewrite the function. So in this case, it's going to be 7x to the 4th. Negative 4 though, because it's a negative exponent. Take the number to the front, multiply it by the number that's already there, because you'll just do that unless you want to do it in 2 steps. So in this case, it'll be minus 28x to the negative 5. And then finally, we have to take the derivative of 102, but it has no x's, so it's 0. So again, hopefully you can see the power rule in action and all these derivative rules in action. They're pretty logical, like you take the derivative of a sum by taking the sum of the derivatives. Same thing with the constants, just leave your constant there, drag a power to the front so that might multiply and things like that. I did forget actually 2 derivatives that we're going to talk about. So for those last 2 questions, we are going to talk about those. So let me erase these. We're going to introduce those 2 derivatives, and then we're going to do 2 examples, and then we should be done. So the 2 derivatives that I forgot to mention is going to be the derivative of ln of x, which is going to be found very commonly on an AP exam. So usually some textbooks refer to it as ln of absolute value of x because they want to take ln's of negative numbers, but the rule is just 1 over x. So if you see ln of either x or ln of the absolute value of x, the formula is 1 over x. Again, we're not trying to explain it. If you want to, you can maybe find resources that explains the proof of this, but we're just going to use it in action in our 2 examples. Finally, one that is very rare, especially on the AP exam, but perhaps not as rare on college calculus exams, is when you have different logarithms that's not just the natural logarithm. Of course, the natural logarithm is ln. So this one is going to be log a to the x. So instead of log base e, we do log base a. And what it is it's this guy right here, 1 over x. And it's sort of the same thing as the a to the x rule. The a to the x rule is a to the x times ln of a for that derivative. It's the same thing, it's 1 over x, but instead of multiplying by ln of a, you divide by ln of a, so that's going to be in the constant here. So let's just see this in action. So again, the 4 that we're going to talk about outside of the power rule, the derivative of e to the x is e to the x. The derivative of a to the x, meaning x is in the exponent and not the base, is a to the x ln a. The derivative of ln of x is 1 over x. The derivative of log base a of x is 1 over x to, ln of a, same in the constant. So let me erase these 2 guys, and then let's practice 2 more examples. So I'm going to erase this. I'm going to erase this. So let's do the first one is going to be f of x. And let's just have 4 to the x plus x to the 4th. And then let's do minus 4 ln of x. And then we can have plus log base log. Then I write the word log. We can write the word log. I never do that, but whatever. Log base 4 of x. And if we want, if you're not writing in pen, forgive me if you are, we can add a 3 here. So we're going to have plus here. And then for the next question, what we're going to do is we're going to have f of x. We're going to have 5 over square root of x minus, let's just do pi to the x. Let's add some e to the x's. And then finally, let's subtract off ln x's. So let's just do minus 3 ln x. So pause the video, take a little bit of time. As you're learning new concepts, it's good to practice them for yourself, and it just speeds up the mastering process, and we all want to become masters, of course, when we're taking derivatives. So just pause the video. No pressure here. Let's wait 3 seconds. 1, 2, 3. Hopefully you were able to do the questions, and let's see what you got. So again, we have each of these is the sum and difference of the things, but you can take every single thing individually. So it's going to be f times of x. What's the derivative of 4 to the x? Do not do the power, do not bring it to the front. This is the a to the x rule because x is in the exponent. So the rule is just 4x to the, not 4 to the x, not 4x, but 4 to the x times ln 4. Again, the derivative of a to the x is a to the x times ln a. If you're tempted to do the power rule, that's for this one. So hopefully you can see the difference between these two. Power rule, a to the x rule. Power rule, a to the x rule. Power rule, a to the x rule. So this one is power rule. You take the 4, drop it like it's hot, just like Snoop said. So it's going to be 4, and then we're going to subtract 1. That's 4x cubed. Now we have two functions that we talked about earlier. There are constants in front of them, but it's going to be okay. Remember, all you do is you just write the constant and then multiply by the derivative of the function. So in this case, it'll be minus 4, because there's just a minus 4 in the front. That's the constant. And then the derivative of ln of x is 1 over x. The best thing to do is memorize these derivatives, but you're going to use this one so many times that you probably won't even need to memorize. It'll just slowly enter your brain through osmosis. Finally, we have this derivative right here, a lot more uncommon, but again, we have a plus 3, so it's going to be 3. And then finally, the derivative of log base 4 of x, that's 1 over x ln of 4. So that's that derivative, the a to the x derivative, power rule, ln of x is 1 over x, log base 4 is this, writing the constants in front of them. If you want, of course, you can multiply 4 and 1 and just write this as a single fraction, 4 over x, same thing as this one, 3 over x ln 4. Hopefully you had time to do this one as well. The only one that might give me a little bit of trouble is the first thing. So again, anytime you have square roots, anytime you have those denominators where just x are on the bottom, rewrite that bad boy as something a little bit simpler, tame that bad boy. So in this case, this is going to be the same thing as 5 times x to the negative 1/2. The negative because the x is in the denominator, the 1/2 because we have a root here. This guy right here, pi to the x, even if it's a little bit complicated, is not going to be the power rule, it's the a to the x rule. So let's get started. We are almost done. I know this is sad that we are almost done, but let's just finish strong. What's the derivative of 5x to the negative 1/2? Well, you just write the 5, and then you just drop the power to the front one last time, and then we're going to subtract 1. So it looks like we're going to drag the negative 1/2 to the front. 5 times negative 1/2 is negative 5/2. What's going to be our new exponent? Just be careful when you're subtracting 1. Some students have missed it in the past. Negative 1/2 minus 1 is negative 1/2 minus 2/2. That's negative 3/2. So that's all good. This is again the a to the x rule, so it's going to be a to the x, where a is pi, so it's going to be pi to the x, and then it's going to be times ln pi. Looks like we're running out of room here, but it shouldn't be too bad. What's the derivative of e to the x times 2? Well, you just write the 2, and then you take the derivative of e to the x, but thankfully, it's the same as itself. So in this case, you just rewrite it, 2 e to the x. E to the x is the best function in the world. Finally, what's the derivative of minus 3 ln of x? Well, you just write minus 3. Then you multiply by the derivative of ln of x. It is 1 over x, so in this case, it's going to be minus 3 over x. And that's it. So we have covered a lot of derivatives. We don't have to use limits anymore. Now we can take derivatives. So in this video, what we talked about is we talked about the power rule very extensively, where we take a number, put it in the front, and subtract 1. And what we saw is that we want to do this process so much because it's not the worst process in the world. So we're going to do this for stuff like this. Things with square roots, things with negative exponents, just by writing it as exponents or powers, because the power rule allows us to find those powers, to take derivatives of things with powers. Then we talked about how to take derivatives of sums and differences. It's very, very logical. You just do what you expect to do. Same thing with constants. Take out the constant in the front. Just take the derivative and then just multiply that thing by the constant. And then we talked about 4 functions that come up here and there, some more than others, but the derivative of e to the x is e to the x. The derivative of a to the x is a to the x ln a. The derivative of ln of x is 1 over x. And finally, the derivative of log base a of x is 1 over x ln a, all in the denominator. So that's it for this video. Hopefully you will eventually become power rule masters. I'm very confident that you will. You're gonna love the power rule as much as I do. Everybody loves the power rule because it's so easy to use. If you wanna practice the power rule and derivatives like this with edx's, ln x's, and things like that, of course we have a Girls Teach Calculus video where one of my former students practices some of these examples. She practices a lot of power rule and changing things to powers like the square roots and negative exponents. So be on the lookout for that. I'll link that in the description below. Like and subscribe if this video was useful for you at all. In our next video, we're going to introduce even more derivatives for you to memorize. Those are going to be our trig derivatives and our inverse trig derivatives. But we're going to be doing the same sort of thing, just talking about constants and adding and subtracting and things like that. Then we're going to do product rule and quotient rule, and then of course chain rule. So hopefully I'll see you in one of those videos. Thanks again for watching, and I hope to see you next time.